In this video, I'll be showing you how to break down complex shapes. This video is going to be a little bit different than other ones. We're going to walk through how to break down each of our examples first. Then what we're going to do is we're going to work in reverse order to show you how to do the calculations when you're given information. For our first example, we have an L-shaped rectangular prism. Now, depending on the information that you're given, there's a couple of different approaches that you could take. Gonna really depend. If I have this side length and I have this length, all I truly need is either this one or this one, and that will definitely need the depth. But depending on which one I have, I'm either going to cut straight down here and look at the volume of this part here, or I'm going to cut this way and look at this volume here and this bigger volume here. The biggest thing is that we want to be able to manage our shapes. It's always easier to simplify than it is to deal with something that's complex. In this next one, we have a pyramid on top of a rectangular prism. It's already broken down for us, so we are going to cut right along here, and that is going to give us, since we already know how to solve both of those, we're going to set that aside. For this next one, we have a cylinder cut out of a rectangular prism. We're going to break this into our prism, and we're going to treat this as if it were a complete cylinder. The difference this time, instead of adding these together, we're going to take the area of the prism and subtract out the cylinder. Sometimes it'll be more than just two shapes put together. Maybe you have three. One of the things that we haven't talked about yet is what to do with trapezoidal prism. Remember, this is our height. This is base either 1 or 2, and this one down here is base 1 or 2. Once you find your area, then you multiply by this width, and there you have your volume. But like I said, we're going to break this. We're going to break this into its components. So we have our trapezoidal prism, we have our rectangular prism, and then we have that smaller rectangular prism that is cut out. Like the example we just saw, we're going to add these two together, but then we're going to subtract out this last one from that combined volume. If I went too fast, rewind or search back, find a good stopping point, and then in between each example, just pause the video and think through what it is that I did and why I did it. All right, we're going to say that this has a height of 10 centimeters, that we have a depth of 10 centimeters. We're going to say that this is 5.4 centimeters. And let's see, this one is 9.5 centimeters, 6 and 2. We'll say 13.2 centimeters for this one. Remember, we're going to break this into each of its parts. We'll start with the trapezoid first. 10, 13.2. I did not draw this to scale. 10, and this would be 9.5. I don't know if you caught that or not, but these two are going to be the same length. Area of a trapezoid is 1/2 base 1 plus base 2 times height. But if we're going to do volume, then we're going to multiply by 10 again. We have 9.5, 13.2, gives me 22.7. We're going to divide that by 2. We're going to multiply this by 100. I like to combine my work so I don't have to fill out a whole sheet of paper, take up the whole screen. 10 times 10 gives us 100. Because it's multiplication, we can multiply in any order. Divide this by 2. That gives me 11.35 times 100. And what we've learned early on in the course was that when you multiply by 100, you move your decimal point back 2 places, centimeters cubed. Now that is just for this prism up here. For the larger rectangle, we have 9.5 times 5.4 times 10, 513 centimeters cubed. And for the smaller one, we have 6 times 2 times 10. So this space in here would be 120 centimeters cubed. So we are going to add this and this together. So 1,135 plus 513, and then we subtract our 120. The total volume is 1,528. So let's go and look at example 3. If I tell you that the diameter here is 6 1/4 inches, and that this has a length of 19 3/4 inch, and this is 8 inches, and this is 8 inches, what would our volume be? Well, we have 8 and 8 and 19 3/4. Length times width times height. If you're using your Casio calculator, we can do 6 ABC, the ABC button, that gives us our fraction mode. 1 ABC button again, so that way we have 6 1/4. Actually, no, we need that for our cylinder. That's 6 1/4, and this is 8. I need 19, ABC 3, ABC 4, times 8, times 8. 1,264 cubic inches. So we have pi r squared times height. The reason that I put in height but not radius is because I have to find the radius by taking 6 1/4, divide it by 2, then I can square it and then multiply. And when we're all said and done, we are approximately 0.4 cubic inches. And then we're going to subtract 1,264 minus 245.4. Total volume of this shape is 1,018.6 cubic. Back to example 2. the height of our pyramid is going to be 1.2 kilometers. This is going to be 3 kilometers. It's going to be 1 kilometer and 1.6. For a pyramid, we know that the volume is going to be 1/3 of the length times the width times the height. One-third times 1.2, because that's our height, times by 1 times 1.6. We get a volume equal to 0.64 kilometers cubed. Remember, this is for the pyramid at the top. Now we have 3, 1, and 1.6. Our volume is going to be equal to length times width times height. 3 times 1 times 1.6. 4.8 kilometers cubed. This time we get to add them together for a total of 5.44 kilometers. I know I've been going quickly through these examples, and I haven't been following the rules for multiplying and dividing based off of how we're significant figures. So I do apologize for that inconsistency, and at some point I will get around to updating this video with that correction. Okay, so for our last final shape, this is the one I want you to do on your own. Here we have 4 feet and 9 feet. This is 2 feet and 13 feet.